Today we learn the simple stresses and strain question and solve the question. Question 1 is, this is written here, the following data refers to a tensile test conducted on a mild steel bar. There are 7 points. The diameter of the steel rod is 25 millimeter. Gauge length equal to 200 millimeter. Extension at the load on 100 kilonewton, 0.14 millimeter. Load on the elastic limit, it gives 230 kilonewton. Maximum load, which is the ultimate tensile load, 360 kilonewton. Total extension of the bar is 56 millimeter, and at the time of the fracture the failure rod diameter is 22.25 millimeter. Now first find the Young modulus or modulus of elasticity E. We know that by Hooke's law, stress is directly proportional to strain. This is sigma by E. This constant is not known as modulus of elasticity or Hooke's law of the material. It measures in GPa or Newton per millimeter square. Now first find the load at 100 Newton, which is proportional limit of load. It is applied for calculating the modulus of elasticity, and we know that the stress is load divided area. Load at 100 kilonewton, 100 into 10 to the cube, and area is area of the bar. This is the pi beta 4d square. This is the original diameter of the rod, 25 millimeter. We put here, and area, we get area 491 millimeter square. The area value is putting the stress equation, and sigma value is 203.7 Newton per millimeter square. And our question gives del L dash at 100 kilonewton is 0.14 millimeter. We apply the strain calculation. Del L dash divide original length L. This is the 200 millimeter of the gauge length. This value is 0.0007 millimeter or 7 into 10 to the power minus 4 millimeter. We put here the sigma and strain value, stress and strain value, and we find out the Young's modulus E, which value is 2.203.7 divided 0.007 Newton divided millimeter square. We got 2.91 into 10 to the power 5 Newton per millimeter square, and it's convert in GPa, then value is 291 GPa, and we get the result of first number. Question finding the first number is the Young's modulus or modulus of elasticity. Now we calculate the stress at elastic limit. Here the stress at elastic limit is given PEL equal to 230 Newton kilonewton. Therefore we apply the stress sigma EL equal to PEL divide area 230 into 10 to the power cube divide 491 equal to 468.4 Newton per millimeter square. This is the stress at elastic limit. Now the percentage elongation, the percentage EL, we note that the given total increase in length del L of the total length of the gauge length 200 millimeter. Therefore, increase in length divide original length into 100, which value is percentage of elongation. Therefore, 56 divide 200 into 100 equal to 28% of the percentage of elongation. At the failure stage, the diameter d dash is calculating the area is a dash equal to 389 millimeter square and the original area is 490 millimeter square. For calculating the decrease in area, percentage decrease in area equal to decrease in area divided original area. Now the decrease in area is a minus a dash divide a into 100. Therefore, we put the value of the original area minus decrease failure area 491 minus 389 divide original area 491 into 100. We get the result of the percentage of reduction in area is 20.11 percentage of the decrease in area, which is the reduction in area at failure of the mild steel bar. Now we find the ultimate stress sigma ut equal to P maximum divide original area. Therefore 360 into 10 to the power cube, which is the maximum load on the mild steel bar, and we get 733.2 Newton per millimeter square. This is the maximum stress on the bar. And we find out the safe stress or working stress. We know that the working stress equal to maximum stress divide factor of safety for the cast iron material. For the tensile material or ductile material, then the yield stress divide factor of safety is known as the working stress. If we apply or we suppose we take PYT, this is the yield strength load is 150 kilonewton. We will first find out the yield stress sigma YT or SYT equal to PYT divide area, then 150 into 10 to the cube divide 490, 305.5 Newton per millimeter square. And therefore working oblique safe stress equal to sigma W is SYT divide FOS 305.5 divide 2 equal to 152.75. Therefore working stress equal to sigma W 152.75, and ultimately we get the all results of the question 1 to question 6, and applying this formula in all the simple stress strength question, we finding the result of the Young modulus, percentage of elongation, percentage of reduction, working stress, ultimate tensile stress, and any other value we can easily find out. If this video is like to you, then you subscribe my channel. Thank you.